Greetings of the day. This is Tejashwini. In this project, we have two primary goals. One is to automatically classify the exercise performed, like say squats, barbells, and curls. And second is to count and segment the number of repetitions that are performed. Though each of them can be achieved independently, we will see that the second one, that is segmentation and repetition count, will help in performing classification better. Now, let's look at the overview of how we plan to achieve these goals. Here, we plan to employ pose estimation models to extract the key points of an input image, and we further perform exploratory data analysis and apply ML techniques on the key points extracted. Outputs of most pose estimation models includes 14 to 17 key points. The picture represents a few of them. We will quickly look into the details of pose estimation models. Now, the pose estimation model is highly accurate, and it gives results even in various lighting conditions or different camera orientations. They are very lightweight models which can be employed in many real-time applications. They are also commonly used in augmented reality and virtual reality applications. One more important thing to mention is that it can work in frames with multiple people. We will further information is provided in the link below. So infinite rep data is used for training the models. In this model, it is a simulated data. It is a simulated data. 10 exercises of the simulated data can be seen here. This data gives about 14 key points and their variation in real time. It also has proper repetition splits and equally balanced classes. As the key points are the final inputs to our models, we can be confident that the same will work for other videos recorded in various conditions. These workouts include arm raises, squats, push-ups, shoulder presses, etc. Now, what are the data points that we have? In case of positions, we have two matrices of dimensions 14 by the number of frames, one for X coordinate and the other for Y coordinate. So key points here include eyes, shoulder, wrists, etc. In case of angles, one matrix whose dimensions are 8 by number of frames are used. Now passing on to Samir.
Thank you, Tejashwini. So I will take it on from here. So let's look at the video with barbell curls of 1 repetition. So let's define something called mean of key points for the entire video. For example, if you see the guy performing a barbell curl, the left wrist, it will keep moving from top to bottom, and this will be the mean position of the left wrist. As you can see the image in the middle, so the left wrist is considered as mean position. So now we subtract all the key points of all the frames with this mean position. So we will get the deviation of key points as in the above plot. So we further normalize this deviation with the height of the person. You can clearly see the plot of the left wrist position also mimic a sine wave. So if you go to next slide. So with this sine curve, can we see cycles now? Can we do repetition segmentation? Yeah, as we can clearly see some cycle here. So how do we segment them into different repetitions? For this, first we tried the autocorrelation technique to find the period of the input, but the time of the repetition for all the videos might not be the same as it is shown in the figure here. So we tried to plot positive and negative cycles and segmented the video based upon change within these cycles. So though this approach is working accurately for our videos, it might fail for various complex movements. So we can try to employ RepNet in such cases. RepNet is a neural network to detect any kind of cycles or a repetition in a video. I have provided an URL for more details about RepNet here. So if you move on to next slide, what different inputs do we have? So basically, if you can see here we have finally 6 representations of the data. To summarize, deviation from the means for the entire video, and then from which we split the repetitions, and then from which we have also took average across all frames to get average deviation of key points in a video. Some of this applies to angles too. So we will use these matrices as representation of input for the various model on the slides from now on. Now my friend Sai Charan will take on the presentation from here. Thank you.
Now let's look at the heat map of average deviations from mean of various workouts. For example, let's observe the leg raise. You can clearly see huge deviation in the left ankle and the right ankle. Let's later pass this information to the decision tree and see if the model can classify the workout based upon the thresholds upon these deviations. We next implemented K-NN algorithms for the above data. As distance is a key metric used, our challenge was to calculate the distance between two sets of videos. So here we implemented DTW techniques, which maps frame to frame between two sequences. So DTW was a customized distance metric which we used in this K-NN function. As these are high dimensional data, it took around 3 hours to compute K-NN for 400 sample input size. We have represented classification for few examples here. Though DTW seems accurate, K-NN using DTW seems accurate, it is time consuming to test each sample of input data we have. Now let's reduce the input dimensions and pass only average deviations into the K-NN algorithms. Here we try to plot 14-dimensional data using UMAP before passing on to K-NN functions. This representation clearly shows the proper distance between various workouts, and the same reflects the accuracy in the confusion matrix using 3 nearest neighbors in K-NN algorithms. In the same way, we also pass angle deviation data. We clearly notice lower accuracy for the case of angles. Let's put the reason behind this question so that we'll answer it at the end of the presentation. I'll further pass on to Vikas to explain decision trees and LSTMs models that we applied on this data.
Thanks, Sean, for explaining how we trained the K-NN model. Now I'm going to discuss about rest of the models. As mentioned in the heat map slides, we have passed these deviations to the decision tree and further classification of various workouts using the thresholds over these deviation values. We have observed that knee and wrist play a key role in classification of the workout. We have achieved 97.4% of the accuracy for this case. So further, going to the next slide about the angles. In the same way, we pass the angle deviation information to the decision trees. Here we have observed the angle between knees and the shoulders play a key role in classification of workouts. In similar way as before, we get pretty less accuracy of 91.1 accuracy, which happened with rest of the angles. As we go into the next slide about the LSTMs, though the decision trees are accurate on this deviation data, we lose the sequential information. There is a high possibility that two workouts can have the same deviation data. So it's better to always have a model which handles the sequential input data. Also, using sequential data, we can predict the workouts dynamically instead of the repetition-based inputs. So let's pass to the entire video to the sequential-based neural network, which is less LSTM. As LSTMs are data hungry, we have 65,000 repetitions, 1,000 videos of data, which will be good enough for training the LSTM model. Passing both angle and positions based sequential inputs, we got 68.5% accuracy and 96% accuracies respectively. We further plan to apply these sequential information to the BiLSTM model. In BiLSTM models are properly known for the perform classification-based tasks. Here we can clearly see that the increase in accuracies respect to angle and positions, which we got about 98.3% in positions data. So, as we have a question about why the angle-based input have lower accuracy than the position-based inputs, which was asked by Charan, answering to that question, angle is not always true between the joints in 2D images. The hugely vary based upon the camera orientation. So we can observe lower accuracy for angle-based inputs. So that clears your question. Thank you. Hope you have find this presentation interesting and helpful. Thanks a lot again.